This is an overview of an article titled APOL1 Nephropathy Risk Variants and Incident Cardiovascular Disease Events in Community-Dwelling Black Adults, published in the June 2018 issue of Circulation, Genomic and Precision Medicine. APOL1 is a primate-specific gene encoding apolipoprotein L1 and has been recently identified as a genetic locus for chronic kidney disease in African Americans. In this issue of the journal, Gutiérrez et al. Set out to address whether APOL1 kidney disease risk variants also associate with cardiovascular disease in African Americans. The APOL1 protein circulates at high levels in the blood as part of the high-density lipoprotein, or HDL, complex. It is widely expressed in a variety of tissues including lung, pancreas, liver, and kidney. In recent years, genetic variants in the APOL1 gene were found to associate with increased risk of kidney disease in African Americans. These disease risk alleles, referred to as the G1 and G2 alleles, consist of protein-coding mutations in the C-terminus of APOL1. Before APOL1 was ever associated with kidney disease, it was known to be a trypanolytic factor in human serum, protecting people from African sleeping sickness caused by trypanosomes. The kidney disease risk variants confer enhanced protection against trypanosomes and thus offer a survival advantage in those with exposure to the parasites. While protective from an infectious disease standpoint, the presence of two risk alleles contributes to the development of different forms of chronic kidney disease in certain individuals, and the mechanisms by which this occurs are currently being investigated. However, whether APOL1 risk alleles also contribute to increased risk of atherosclerotic cardiovascular disease remains unclear due to conflicting findings from prior studies. Gutiérrez et al. Set out to address this issue in their analysis of data from the REGARDS cohort, an observational study of approximately 30,000 adults from the southeastern United States, also known as the Stroke Belt. This population has a large sample size of African Americans. 1,346 participants with high-risk APOL1 genotypes, defined as the presence of two G1 or G2 risk alleles, were identified. Out of all currently published APOL1 cardiovascular studies, this cohort has the largest sample size for high-risk APOL1 genotype. Crude analyses of cardiovascular outcomes did not demonstrate a statistically significant association between coronary heart disease or composite cardiovascular events in high-risk genotype. However, when the analysis is stratified by diabetes status, participants with a high-risk genotype and no diabetes history have significantly higher risk for cardiovascular events, which consisted primarily of stroke. This result occurred without significant differences in baseline blood pressure and with only marginal differences in lipid levels, including HDL. When the analysis was stratified by chronic kidney disease status, those without chronic kidney disease but high-risk APOL1 genotype had an increased risk of ischemic stroke. This work adds to a growing body of literature that APOL1 kidney disease risk variants may play a role in the development of cardiovascular disease within specific African American populations. This work also emphasizes that more studies interrogating the association of the high-risk APOL1 genotype with cardiovascular outcomes are warranted.